great to have the opportunity to show also our products here in this webinar. So I'm Matthias Finke, working at Leine Linde and taking care of the wind, the whole wind applications within our group. And so Leine Linde is a company located in Sweden, and we are a sensor and solution providers for various industries. And within the wind industry, we are almost now 20 years in different applications, in applications where it's in motion, so generator encoders and pitch encoders and these kind of things. And today I like to show you about our strain sensors. Our strain sensors in cooperation with Beckhoff, and the strain sensors themselves are used or can be used also in various applications where you can expect tough environment. And of course, in this case, we look into the application for the wind turbine. Within the area of the wind turbine, we offer a range of a scalable solution. You can see starting from the raw sensor, just the pure sensor, over the library. This is a topic for today, which we provide for the twin cut, for Beckhoff twin cut, and then to a final solution, even calculating the bending moments in the rotor. And as mentioned already, in this short webinar, I will introduce the new developed ESR extended sensor library, as we call it. And before this, I'd like to give you a short introduction our sensor technique. So the ESR strain sensor, it's now on the market since about 4 years. It's basically a digital strain sensor based on a rotary encoder and having a measurement beam of 200 millimeter, which defines exactly the length of the strain, where we measure the strain in the root section of the blade. The core functions or the core features of the strain sensors is that we have a very high resolution when it comes to the strain measurement, which is about 0.025 micro epsilon, where you usually have with classical strain gauges about 0.5 micro epsilon. So it's 10 to 20 times more than a classical strain gauge. And that's in combination with a huge measurement range of plus minus 5,000 micro epsilon. So even though in the headline we said the sensor, it can be used for rotor blades out of GFRP or even glass fiber or carbon fiber, it can be also installed in many other on many other material where you can expect a wide range of strain or load. Also, the steel tower for windmill is not an issue. And the advantage which comes with our strain sensor is the inbuilt temperature compensation, and the simple but very, very good idea behind this is that the measurement beam here comes with the same thermal expansion coefficient than the object to be measured. And so for that reason, we passively compensate temperature effects. Due to the provided interface called NDA 2.2 and the embedded electronics, we can also provide strain sensor data up to 30 kilohertz of sampling rate. With the sensor itself, you also get a high IP rate. We, since the installation place is in the blade, in the root section of the rotor blade, is according to the IEC 61424. So with our lightning protection concept, we can also survive the lightning hit when it tips the blade. And another feature when it comes to the sensor is that we basically have stressless measurements. So we can cope with more than 300 million cycles is what we have tested, and this is much more than usually used in the rotor blade. Also, a great advantage of our embedded electronic, of our ASIC, which we are using, is that it provides online diagnostic of the sensor itself. So you get temperature information, you get also a diagnostic value of the sensor itself. So you can run a certain, with this information, you can have a possibility for predictive maintenance approaches. The sensor variance itself, as mentioned already, we differentiate between the different beams. So we offer different type of material for the measuring arm. And this is just a small selection of the variants we have already. So depending on the material you like to measure on, we provide you with a related measuring arm material to compensate the temperature effects. And then in addition, we have different possibilities to install. So a classical way of installation in the rotor blade is to glue the surface to the rotor blade, but we also, when it comes more to the tower, for instance, we can also screw the sensor into a steel structure, or even for time-limited measurement campaigns, you can also the magnet connection, which is then very simple for the installation, and it's done in a couple of seconds. If we now look especially for the installation in the rotor blade and also tower, together with a hardware from Beckhoff, as an example, you can see here this is for blade bending moment measurement. In this case, you can just simply use a Beckhoff PC series, IPC series CX5100 together with the EL5032 input card, and by using one input card, you can directly connect up to 2 strain sensors, and you are already with this connection directly in the Beckhoff automation world. So that makes the installation of the whole setup from the strain signal up to the usage in the control system very easy. And the same goes for the tower installation. No matter if you're in the tower top or tower bottom, you can also use here the same setup using the Beckhoff IPC together with a EL5032, and then you're ready to go. And since we provide our ESR extended library based on TwinCut 3, and we provide this library to you. This is a full integration into the TwinCut world. So there's just required, as mentioned earlier, the I/O card from Beckhoff, and then based and by using our library, you get several information which are either directly out of the sensor or pre-calculated in the project out of this library. And to give a short summary about the input, or especially about the output, we made this library in C++ for TwinCut 3. So when you're using Windows 7 or Windows 10, this should be possible for you to use. And what you can expect as an output is you get the real strain information and temperature information in microstrain or even in nanometers, and you also can do the temperature sensor, the local temperature of the sensor. Furthermore, by using the library, also the sensor itself, the sensor signal itself is monitored continuously. So if you have a freeze of the strain sensor, for instance, or of the temperature, this is monitored and highlighted via an error message to your upper control system. And then you have full access and easy access, especially to the inbuilt sensor diagnostic. So in each moment of operation, you can have the information from the sensor if it's going good or bad, especially when you use those kind of sensors in the control for a turbine in the rotor blade. Then such information is very helpful. And especially for the series installation, but also for measurement campaigns, it's with this library, it's very easy to get the type label information out of each strain sensor. So it's very easy to build up your digital documentation around your project. The gain, what you can achieve with this library is that you get a full digital chain, which is highly synchronized from the single sensor up to the turbine control system, and even perform integrated condition monitoring with it. You can have very easy data access by using our strain sensor together with the ESR extended sensor library, and so you have the possibility to have the full access to the embedded information. And the pre-processed strain sensor data, which there is some calculation done in this library. It also supports your system calibration procedure, and also, as said before, performs continuous signal monitoring. So this allows you to have a very simplified and easy access to the data, and also supports you during operation of the system. It is, if we now look for the different applications where this set sensor and library can be used in, it is of course obviously for the wind turbine control, for individual blade control, where the sensors are installed in the root section of the blade, and by using our components together with a back-off environment, of course you can provide intelligent control algorithms to reduce the structural loads of the blade, and even also on the tower, since the sensors can be installed also in the tower, and also increase the overall energy yield of the single turbine. Even more, when it comes to fatigue loads, you can also perform structural monitoring and calculate the fatigue loads over the lifetime of the turbine. So as heard already earlier, with this type of information, it's also feasible to think about lifetime extension approaches. And beside these type of fixed installed applications, there's of course with a simple installed and reusable type of strain sensors, it's also possible for research and development, and also up to the type certification, where we also provide certified strain sensors. Those installations are now done in more than 10 countries around the globe in different applications. So we have a good overview of different applications, and that runs very nice. And for instance, here, this is just as an example, some pictures from installation in one of our blade installations, where the root load was measured, and here you see how the sensor is installed and how the wiring is done. And yes, that's already what I like to show you, what I like to share with you, and I'm happy to receive your questions afterwards. So yes, that's it. Thank you.